Hey guys, welcome back. Today we are going to be continuing our lesson on energy by talking about the difference between kinetic and potential energy. Now, as a refresher, there are different types of energy that we've already talked about. So energy is the ability to cause change, and it's measured in joules. So when you see that unit J, just know that's the unit of the measure of, or a measure of unit of energy, which is in joules. That's J. Today we're focusing on the difference between kinetic and potential energy. And kinetic energy is just the motion of objects, and then potential energy is stored energy. And we'll get into that in a little bit more detail here in the upcoming slides. There's also electrical energy, which is the motion of electrical charges, so a flow of electrons. Chemical energy, which is the bonding of atoms. We've already talked about that in this course. Nuclear energy are changes in the nucleus of an atom. So think about like atomic bonds, nuclear energy from nuclear power plants, fission and fusion. And then thermal energy, which is the internal motion of particles. So we talked about conduction, convection, and radiation all the way back in Unit 1 as well. So a lot of this that we're seeing today, thankfully, is going to be a review because I know you guys also talk about potential and kinetic energy in like the 8th grade as well. So hopefully this will just be kind of a refresher for us today. Okay, so kinetic energy is going to be energy in the form of motion. So any object that is in motion has kinetic energy. So like if you're moving around right now, you as an individual has kinetic energy. It's going to depend on mass and velocity. Okay, remember velocity is speed with direction. So how fast is something moving and how large is it? If you double the velocity, you're going to increase the kinetic energy by a factor of 4. Okay, we're not doing any math yet today, but we do need to keep this in mind moving forward. Okay, so if you double the velocity, we're going to increase that kinetic energy by 4. So taking a look here, really quickly, we have a big tanker truck, and then we've got two smaller motorcycles. Okay, so the motorcycles definitely have less mass, and they're going slower than the truck, right? So, or the one is, so the one here, he's going 50 kilometers an hour, and then this motorcycle is going 80 kilometers an hour. And then this big tanker truck, he's going 80 kilometers an hour. So the truck has definitely a larger mass than either of the motorcycles. Okay, so he's got a larger mass, and then he's going pretty fast, right? He's going 80 kilometers an hour. So he's going the same speed as this motorcyclist right here. However, because the truck has more mass, he's going to have more kinetic energy. So in this image, just from these three objects right here, the tanker truck is going to have the most because he's got the most mass and he's going the fastest. And then for the least kinetic energy, we've got to compare these two motorcycles because they're exactly the same. So we're assuming they have the same mass. But this motorcycle right here is going a little bit slower. So he's going 50 kilometers an hour versus 80. So he's going to have the least kinetic energy. Okay. So velocity and mass do impact kinetic energy. So the SI, the Standard International Unit of Energy, is the joule. So it's going to be abbreviated J. So when we start doing calculations in this unit, please remember no naked numbers. We always want to include the units. And then, as an example, if you dropped a softball from a height of about half a meter, it would have a kinetic energy of about 1 joule before it hit the floor. And the kinetic energy equation, kinetic energy is equal to 1/2 mass times volume squared. Okay, so if the energy in joules is equal to the mass in kilograms times the time in meters per second squared. Okay, and that's again velocity, v squared. Now, we're not going to do calculations today. We're just focusing on the difference between kinetic and potential energy, but I do want you to keep this in mind moving forward because we'll talk about this more in this unit. So then potential energy is kind of the opposite of kinetic energy. It's the motionless objects that store potential energy. Okay, so potential energy is energy stored in the object. An example would be like a hanging apple in a tree, and then it's due to the position. Okay, so energy due to position is called potential energy. So these apples, they are not in motion, right? They're hanging on the tree. They have a position above the ground. They have potential energy. They have the potential to be in motion. Okay. So potential energy is stored energy, and it depends on the position or the configuration of an object. So taking a look here, we have this boulder. One is at the bottom of the hill and one is at the top. So when you're asking yourself which object has a greater potential energy, it's good to keep in mind like which one has the greater potential for movement, right? So in this case, it's going to be the object with the higher position because it's got a greater potential to move down the hill, right? So in this case, the boulder with the higher position will have a greater potential energy, okay? So these are some other examples of potential energy. One of them is elastic potential energy. So think about a rubber band. So if you stretch a rubber band and you let it go, it contains kinetic energy, right? When it is in motion, it has kinetic energy. As it flies through the air, it's in motion, kinetic energy. However, where did this kinetic energy come from? It comes from the potential energy in the elastic of the rubber band, right? So when you stretch a rubber band before you let it go, the band itself has energy stored as potential energy, right? It's the potential for movement. Then when you let it go, it's got the kinetic energy as it flies through the air. And then once it stops and reaches its landing place, it goes back to having that potential energy. Okay, similar thing in like a rubber spring as well. Chemical potential energy is like, think about gasoline. So that stores energy in chemical bonds between atoms. So we talked about combustion reactions in this course already. Remember, you always have a fuel source in the form of a hydrocarbon. So gasoline, propane, ethanol, some kind of hydrocarbon that has carbon and hydrogen bonded together. The energy in those bonds is stored as potential energy. It's released when that fuel source undergoes combustion, right? When it's combusted, then it releases energy, and that's kinetic energy, thermal energy, but just in the form of gasoline or whatever that fuel source is, it has the potential for kinetic energy in its bonds, so it's contained in its chemical bonds. Gravitational potential energy is anything that can fall and has stored energy is gravitational potential energy. Okay, so it's also referred to as GPE. That's just a little abbreviation for it. It's energy stored by objects due to their position above Earth's surface. So, again, the apple tree example. The apples hanging on the tree, they are above Earth's surface. They are not moving, so they don't have kinetic energy, but they do have the potential to move. So their position, the higher the position they are, the more potential energy that they are going to have. Okay? And if we remember, on Earth, the acceleration of gravity is 9.8 meters per second square. Okay, we used that when we were talking about Newton's forces in our last unit. And that is it today. So all we need to know is that the difference between kinetic and potential energy, kinetic energy is in motion, potential energy is stored either in chemical bonds or in position, so it's the potential for an object to be in motion. The higher the position, the more potential energy it's going to contain, okay? Keep in mind these formulas that you've seen today because we will move forward with using those formulas, but for today we just need to know the difference between kinetic and potential energy and knowing how to identify which object has the most kinetic or potential energy. If you guys have questions, of course, let me know. If not, I will catch you guys in the next lesson.